Hi guys, welcome to the Study Bubbly podcast. Today we're going to be talking about AP Computer Science. We're going to be discussing Java Unit 1. There may be some examples in the notes that we've provided that we will be referencing, and we're going to provide videos where we work and collaborate on an IDE together so we can all work together to show you just what we mean and help you understand this unit a little better. I'm May.
I'm Shadow or Vince.
I'm Jason.
And I'm you again, or Jeffrey.
So just some basics, I guess. Commenting. So for commenting, it's really simple. It's 2 slashes. For single line, and it's a slash and an asterisk for multi-line. So should we do an example?
So yeah, this here is what a comment would look like. This here is a single line comment.
Okay, so yeah, this is how you comment. There's a couple different ways. So like this one mainly is important because you can put a lot of space between it. So if you want to write like a lot, but it doesn't like all fit on a single line, then this is pretty helpful. And there's another cool thing you can do, like if you do like, oh wait, I'm writing inside the comment. Sorry. So if you write a line of code like this, at least on my Mac, it's command slash. You can just highlight over anything and do command slash, and it'll automatically turn them into single line comments for you, which is pretty convenient if you want to test like a certain part of code and don't need the other parts to be also running. I use it all the time because my code doesn't work. You didn't hear that. It's pretty convenient, is what I'm trying to say.
That is a mood though when your code doesn't
Yeah.
work.
Yeah.
Oh
You can
my
also select
God.
multiple lines and do the same thing.
Yeah, it'll just do that.
Yeah. It'll turn them into single line comments though, not multi-line comments, block comments. So keep that in mind.
Right.
Yes.
All right. Who wants to talk about identifiers in Camelcase?
I know what Camelcase is.
All right, start with that.
Are we starting with that? So identifiers, I don't really use that term, but it's basically just like variable names, I guess. Right? I'm not being stupid.
Yeah.
So they're basically just like variable names. Like we're gonna learn about variables later more in depth, but this is essentially I'm writing inside the comment. Can we please get rid of this?
Just make the comments smaller, I swear.
Yeah, they're just in the way. So I'm gonna write the name like about right here. And usually if you have multiple words in your variable name, like if I wanted to name it fifth number or something, then the order it goes is like this, and then you'd put like in a value. But the thing is, you start with, Camelcase is basically starting with lowercase words, but each consecutive word just starts with a capital letter. So it looks kind of like a camel, because every so often there's a little hump where the capital letter is. And I don't know how else. That's why it's called that.
I mean, yeah.
You described a camel as every so often there's a little hump. That just cracked me up. It's fine.
I mean, that basically is a camel.
You're not wrong. No, yeah, you're not wrong. You're not wrong.
Thank you.
Yep.
And so like if you wanted to go really excessive, I guess you could be like, oh wait.
Oh.
My name is for.
Wait, I gotta keep this PG.
Oh my god.
Oh my god.
So like you can see here, like it always starts. I don't know if this is helpful. I feel like you guys probably get the concept, but it's just an example.
It's fine. It's fine. Yeah. Keep your variables short though. Just.
It makes things easier to understand and easier to comprehend.
It usually shouldn't be as long as this.
Yeah, like you should, your variable names, like you should definitely understand them. So it's not a good idea to just name it like
Timmy
X or something, because sometimes you're just not gonna remember what that means. Like there are a couple that are by custom letters like this, but they're really common, so you'll know what they mean. Like I and for loops, which we will be getting to later in further units. But you don't have to worry about that. It's just a generally good idea to make sure you name your variables about things that are easy to remember but also easy to type.
All right, so for errors, there's 3 types, but talking about 2 first. The first one is syntax or compiler error, and the second is logic errors.
Okay, so I
Yeah.
can try to write some common syntax errors. Like if you just tell me what you want, like what examples or like talk about examples you want to
maybe.
use, I can try to write them.
Okay.
Okay.
Like
Maybe
Would it
we
be too
should
much if I
do
use an if statement?
syntax
Because I was
first.
gonna do like equals equals as a syntax
No, just
error.
just use prints.
just leave off like a
Just use
curly
prints.
bracket or something.
Yeah.
Parentheses. Okay,
Oh.
right. So if this will make a syntax error because it doesn't know when it ends.
Well,
Or, I don't know,
also
you
because
guys
the
talk
S
about
is
that.
lowercase. The S is
Yeah.
lowercase. That's why it's
It's-
gonna
Yeah,
have a
Oh, right,
syntax.
yeah. That
So
will
yeah,
be
syntax.
an issue.
Right. Syntax compiler errors are basically it won't even let the code run. So these are actually, in my opinion, these are the easier errors.
Yes.
Usually
Because-
the IDE you use will notify you about these. It'll tell you like, hey, you're missing a semicolon, or hey, this needs to be capitalized.
Yeah, or
It's
like,
right.
you didn't complete a bracket, you didn't
Yeah.
complete parentheses or something like that.
mm-hmm.
Or even you just left off a semicolon from the end of your
Yeah.
line.
Right.
Yeah.
That's very common. And the second thing is logical errors, and logical errors are much harder to find because like it does print it out, but it doesn't print out what you want it to. So should we do an example of like saying like a phrase?
Usually it's an issue
I mean,
with like the way
loops
you've
and
coded
stuff.
it. Because
Yeah.
this is mostly stuff like loops, if statements. It's when you start getting into the logical part of your programs.
Right.
And when they
Right.
start getting more complicated, that's usually when you'll
I mean,
make
we
logic
can-
errors. So like a common logic error, you're probably going to learn about if statements pretty soon. So if you put like if 3 was greater than 5, that's obviously never going to print. I don't know. That's like but also if you want it to do something, but like you forget, if you want something to happen in your if statement, it's only going to happen if this is true.
Here, I have an example. Okay, so let's say you want to print hello everyone in the same line, right? So if you run this,
Mhm.
whoever's screen sharing, can you run it? Because I don't know if I run it, it's gonna lag.
Yeah,
Okay, it's running.
it is
Um,
running.
Oh my god.
Oh,
What is it?
oh.
We
Oh.
already
It's
have
got
an
an error. It might
So that is
be
a prime example of.
All right, let's
2
try and
errors.
debug this.
This
What
is
lines
so
are they?
sad. This is so sad.
No, it's fine. We can debug.
It looks
You
like there's
see-
an issue here. I think this should be red.
Yeah.
Yeah.
We can delete this. We
Oh,
don't need this anymore.
yeah, delete that. I have no idea why this string is weird. Okay, run it again.
Anyways, that was a key example of what you get when you have an error.
Goatee.
100% planned, 100%.
Exactly.
Yeah, we obviously did this just to make an example for you. Like,
Okay.
see, it's working now. That's an example of
Okay.
debugging. Sometimes you just
So-
gotta delete your stuff and start
Okay,
over.
back to our point. You want to print hello everyone in a line, but what you're doing is you're printing hello and then you're printing everyone. My ears just died. And that's
Everyone
rough.
on a new line.
Oh yeah. So there's a difference between these 2 lines. Like this one says system.out. Or it used to say system.out.println or line, however you pronounce it. It depends on the person. And this one says system.out.print. So essentially what print line does is it will create it's called a carriage return. It's like pressing enter. And then it'll do this next line. But if you don't, like now it's print, it's just going to print hello everyone on one line, like you just
Right.
saw.
So that's like the types of logic errors. The other types is like what May was talking about with the if statements and that sort. It's more like, yeah, we'll get into that later. We'll worry about it later.
Yeah.
Yeah.
It's
Okay.
fine.
Like the
Basic-
important thing is just to know they exist and be able to recognize certain types of issues because like I don't know, like logic errors, like your code will probably still work. It's just not going to give you the result you want.
Right.
While like compiler errors, and there's another type of error that's like runtime error.
Exceptions. Yeah.
Yes.
Yeah.
I didn't talk about those because those were more in Unit 2.
Yeah, this is Unit 2 stuff.
Yeah.
But these are just the important errors to know for now. So yeah.
Next up is
Okay.
printing and data types.
We kind of did printing, so we can just move on
Yeah.
to data types.
All right. So primitive data types, which are basically what your bulk of Unit 1 is covering, at least what we covered mostly in Unit 1, is how do you explain what a data type is? It's
Like,
literally
the
just a type
variable-
of
It's
data.
the type. Yeah, it's literally the type of data.
Yeah.
So you're gonna have a lot of different types out there. You have like longs, floats, chars, but the main ones you're gonna need to know are ints, doubles, booleans, and chars. Those are the four main ones you're
Ints,
gonna
doubles,
need to know.
what in char? String?
Ints, doubles, booleans, chars.
Oh, booleans. Sorry, I wasn't paying attention.
It's
I was
okay.
like, I should write these out so people has eyes. Really?
I
That was such a stupid bool.
okay.
Why is it even okay? Okay, moving on. So
Moving on.
going from
So yeah,
simplest to most complicated. First you have an int. An int is basically any number within the range of like I don't know, is it like 9 to times 10 to the
it's such a
34th
large
power or
number.
something like
It's
that.
probably unimportant, but I would recommend not going past the trillions.
Yeah, you're not going to need such a large number, and you're
You
not going to
probably
need to
won't.
know
If you
such a
do,
large
that's
number.
another problem. But for our purposes,
I would be
and
concerned if
especially
you
the
were.
AP test, you will not need to know how far it goes. But it's just rest assured, it's a really large number. You can probably look it up. And I think it's in our Unit 2 notes for any of those who are interested.
It's also important to know that ints, like integers, which are what it sounds like, they can only be whole numbers. So you can only have like 0, 1, 2, 0, -1.
Right, no decimals.
Yes, because that would make it a double, which is the next type of data type. These are basically ints, except you can use decimals. Up to I keep wanting to say like 34 decimal places for some reason, but I don't think that's correct.
I don't know. I can't verify. It's some number.
Once again, you're not going to need to know this. And
They're not going to test you on how many values you need.
And there's no reason when you're coding to need 34 decimal places anyways, even if it goes that much. Moving on.
Short. What was the purpose of that? You just ruined my line.
God.
Do you know how to type?
In your mind, do you know how long like a billion seconds is? Like, just want to throw that out.
It's like a lot, isn't it?
Yeah, like okay, so 1,000
That's
seconds is like 16 minutes. A million is
Shadow, why do you
11 days. I'm searching it up on Google, man.
Billion
Oh,
is
okay.
like
That
like
makes sense.
I remember hearing this about like years because like one of them
Yeah,
like
billion
not long, and
billion
it's, like,
is
30 years or
31
something.
years. Yeah, billion is
Yeah.
31 years. And trillion is
Wait, so what place does
trillion is like
integers
31,000
go
years.
to?
So
Okay. The largest number an integer goes to apparently is, let's see, tens, thousands, million, 2,147,483,647.
That is a lot.
That is
just
such
don't go
a
That
past
is-
like 2 billion and you're good. 2 billion or negative 2 billion and you're good. So it's like 4 billion numbers you have. You really don't need
that's
more.
a lot.
yes, because
Okay.
2 billion means you have 4 billion numbers.
No, because it goes from negative 2
Yeah,
billion
it goes
to
from
2
negative-
billion.
Yeah, I know.
Okay. All
And
right.
then-
Okay, so these are the important. They're known as primitive types because they are the simplest data types made, there's going to be other data types that will use these data types to create different kinds of data types to be manipulated. Like one of them that's going to be pretty common is string, which we will be discussing them in depth in Unit 2 again. But they basically look like this.
It's basically a string of chars.
Yeah, it's just a bunch of chars.
You're putting it outside the.
Is May about to commit another error?
Oh my god, shut up. No, I never make mistakes.
Of course.
Okay, wait. What's up with the lines? The white space shouldn't matter.
You need to put it.
Because as long as it's behind the brackets, it should be fine in Java. Because Python's the picky one, isn't it?
Yeah, Python is very picky.
I mean, it looks
Java's
stupid
more
if you
picky
don't.
than Python, in my opinion.
Really?
No, because I hate using Python because you always have to like tab everything or it doesn't work
What
right.
do you mean? Oh wait. If you're talking about spaces, yeah, I guess.
Yeah, like indentation and stuff like that.
But that's not that difficult.
After doubles, you have chars, which I don't know a lot about chars. I feel like May could tell.
They're essentially single characters.
Yeah, each of them has a number that corresponds to them, which is why you can also make chars equal numbers, like 127 or something. And it'll, if you like printed it or something, it would display the number corresponding on the ASCII table, ASCII. You can look it up. It corresponds to all the possible characters, and that'll be the character it corresponds to, I guess.
Right. I think at Unit 2...
This is helpful in some things, because you can also like compare chars, I'm pretty sure. Like, I don't use it very often, but I'm pretty sure you can do that.
Yeah. I think at Unit 2 or 3, we need to convert it.
Yeah, okay.
Yeah.
And you don't use quotation marks to write chars.
You're supposed to use
you use
single quotations.
Right.
I think they're apostrophes, but whatever.
Yeah, well, this actually run.
Single quotations, whatever.
Oh, well.
Yeah, I don't think we...
Why do we keep making errors? This is why you don't use floats. This is why you use doubles. They're more precise anyways. Floats are outdated.
Doubles go to 16 decimal places, by the way.
Great.
Yes, very important. Yes.
Definitely you need to know that.
Theoretically, we did instantiate that float correctly, but who cares?
Wait, did we ever get to initializing and declaring the differences?
Oh, we should probably hit on that.
Yeah.
The other irrelevant primitive types that aren't going to be found on your...
Jeffrey, we should go over the relevant one first. We haven't talked about booleans yet.
Oh,
that's probably... These are named after, like, John Boole or something. They're booleans, and they're basically, like, two values, true or false. That's essentially it. They're pretty lame.
Yeah.
They're actually not. They're very useful. They don't seem like it at first, or they didn't to me, but they are actually pretty useful if you need, like, a yes or no kind of thing.
Especially once we get to, like, logic statements. You'll use boolean.
Right.
Yeah,
so
they're really helpful for logic
return
statements.
a true or false statement, which is a boolean value.
Yeah.
Right.
They all are essentially booleans, and you can like set boolean values to logic statements, which is also pretty nice.
Right.
Yeah.
But they're going to be more important as you code more and more, and I guess you'll see it eventually. But yeah.
And now getting into the irrelevant types. Nobody cares about these.
Jeffrey has been waiting all day to get into these.
A byte is like a store brand integer. It's a lot cheaper, and it's usually not as good as the brand name because they only go to like negative 127 and 127. But they save memory, and that's like they take up a byte.
And short and long, they're pretty much the same. Shorts can store more than bytes can, but less than integers. And longs can store the most out of all of them. And floats are basically off-brand doubles.
Right.
They they go to, I think, I'm not sure, but
I
essentially
think
they're
it's I think it's like less precision,
Yeah.
not
they're
necessarily
less
Yeah,
less
it's less
value.
precision. Yeah. I remember when I was programming, I always used float. I don't know why, but
Yeah,
you-
but like okay, so they can go to like the same number of values essentially. Like what we mean is like they don't go to as many decimal places.
right.
right.
Yeah.
Okay, so
Just-
should we
just
move
so it's
on to
clear.
1.3, 1.4, and
It's-
1.5? You know that we
Oh,
have three
no.
sections. It's fine.
So now that you know what the primitive types, you should probably know how you're going to use them and create them, which in
Right.
comp sci talk is instantiating and initializing them. I
Or
don't know if
declaring.
that's actually true. I just guess.
Okay.
To initially create a variable, you have to declare a variable. So, for example, if you want to create an int that represents a score, you'll have int score, and it's not set to any value. So, all you're doing here is you're declaring the variable. You're not setting it to any value. And what you do to set it to a value is, did you really just delete mine and write yours?
Oh
Yeah.
my god. Anyways,
What you're going to do to initialize a variable is you're going to set it equal to a number. And that assigns a number to the variable.
And
Um,
like obviously for non-number ones, you're gonna assign like this kind of stuff. I mean, you can
Right.
assign a number to a char, but like you can also assign letters. So whenever you assign letters, unless the letters make up a word that equal another variable of the same data type, like a variable name of the same data type, like you're gonna have to put it in quotations. And yeah.
And like, I think I'm not wrong, but like after you say like, for example, int score equals 2, you change it in the next line, score equals 3. I don't know if I'm right or
you
wrong.
don't have to.
Wait,
you don't have to
int what
declare it
equals
again. To modify it, you just need to directly.
Yeah, after
use the
you
variable name.
set the data type, whenever you
Right.
add or like whenever you mess with the value that it equals, you don't have to put the data type again.
Right.
You can just use the name because it already knows what data type it
Right.
is.
And going back to setting logic statements equal to booleans, you could do something like this. And
Or you could do
Not
like
like
if you
this.
want to use variable
Right.
names, you could use like
Right.
can you even put equals in here? Yeah.
Wait, are you sure this is 1 equals 1?
I mean,
One?
like this isn't 1 is 1 anymore, but I'm just like demonstrating an example of how you could use like a
Okay,
logic statement. So an important thing to note here is that equals is for setting values. If you want to find out if something is equal to another thing but not change their values, you use equals equals. And that's important to remember when you're writing your logic statements because you could end up just like if you set something like 1 is 1 equals score when you're doing a logic statement, it's always if you're using that as the basis of your logic statement, I'm pretty sure it's always true when you do an action such as this because it completed the action, therefore it is true. But if you want to check if 1 is 1 equals score, which it doesn't since they're different data types, but theoretically you would put equals equals like here, I guess.
It would just be a compiler error, I think.
we
Is
don't
it a
go
compile
over.
error?
Right.
I know like for some actions, like it just uses
I think
true.
A syntax
when
error. A
some
syntax
action
error.
Yeah, it would probably be a syntax error if you try to compare
I mean, syntax is
different
compiled.
data
but-
types.
Yeah.
Syntax is syntax after all.
Yeah, so don't compare different data types. But if you're just like if you accidentally just use like equals for two data types, I'm pretty sure it counts as an action. But you really shouldn't be doing that. So
Okay, yeah. So wait,
important
so on the subject of on the subject of equals and that sort, maybe we should talk about operators. So addition, subtraction, multiplication,
yeah.
division, and modulo. So you guys already know the first four. Hopefully, if you don't, I can't help you with that. So
Go back to
modulo
school.
is modulo
You
is
should be
basically
taking AP classes.
modulo is basically the remainder. So let's say 13 divided by 4, right? What's that?
It's 1.
It's 1, yeah.
13
Modulo,
divided by 4?
No,
yeah,
okay.
the modulo. The
Oh,
modulo.
Okay, 13 mod
I thought
4.
you said
is-
what is 13 divided by 4, not what is the
Okay.
remainder. My brain was just like, what? I know what modulo
Okay.
is. Please don't kick
4
me
goes
out.
into 13 3 times, and with a remainder of 1. So what it would return is 1.
Right.
So this is how you use modulos. This one is going to be 3 because you can't divide 4 into 3 any times. So the remainder is 3. If I put it like to 9, 4 goes into 9 twice, so the test is going to equal 1.
Basically, the operator sign for a mod is the percent sign.
Right. Okay, so I think we got that covered.
Yeah.
It seems like it. If they have questions, they can ask us.
Basically, this works in the same way as normal algebraic functions, except for modulo.
On the topic of operators, when you try to divide by 0, that's going to cause an arithmetic exception to occur, which is
Right.
which is a logical error,
Yes.
since you can't divide by
Right,
0.
you can't divide by 0. Yeah.
Oh, right, yeah.
Okay.
So-
Moving on to compound. So, there's a simpler way to add and subtract, divide, etc. Different whatchamacallit?
Variables?
Functions?
Yeah, variables.
Yeah,
Variables.
that. All right. So again, it's addition, subtraction, multiplication, division, and modulo. Maybe you want to split it up. I'll start with addition to subtraction then.
Okay, if
Okay,
you
so-
just talk about it, I'll write it. That's like the only thing I can do.
Oh, okay. So addition. So for addition, you can use it, for example, if you define a variable x equals 6, you can say like 6 plus equals 3. That would add 3 to the integer 6. Same thing goes for subtraction. You have the variable x, and then you subtract equals 3. So that would subtract 3 from the variable.
And it goes for multiplication and division. I'm not sure. I would assume so for
Yeah.
modulo. I'm not sure though.
Yeah, it's the same
it does work
for
modulo.
all of them. Yeah, so it's the same for all of them.
And then
Can't put
you can also do the name of your variable plus plus or minus minus.
Right.
Add or subtract 1.
That's called incrementing.
Yeah,
and
we'll talk about that later.
Casting.
Do your magic.
So essentially what you're doing is you're taking a variable of, I don't think it has to be any specific type, but
the ones that we were most commonly going to use are like int and double.
yeah, but you're basically
Right.
changing it into a different form of variable. Like you're changing an int into a double or double into an int. And
Right.
in the case that you're changing a double into an int, it truncates, meaning that it just straight up cuts all the decimals off and says those are unimportant. And anything, if you change an int into a double, it's just replaced with a bunch of zeros. There's nothing really there. I don't know. These are just useful because like it saves less effort.
It's not as long to type as like x plus equals 1 or x equals x plus 1. It's just a lot faster, and if you only need to use 1, which is common in loops, for instance, which we
For
will get
loops.
to eventually, but
Yeah.
it's
Right.
a useful feature you're going to learn. It's useful to know now, I guess, while you're learning about operators.
Casting is basically you're taking one variable and you're assigning it to a different data type. So like you're
Yes.
taking a double and you're turning it into an int.
Quickly summarizing, make sure you know what prints are, the different data types, operations. There's also the complex operations, I think. And then the casting. That's the basic overview. There's commenting and errors too, but that's on the side. Thank you everybody so much for watching. Make sure you check out our other podcasts and subjects. Check out our website where you have more resources. Make sure you share it to your friends and you like and subscribe if you're on YouTube. Make sure you follow us if you're on Spotify. This is me, Shadow. I'm here with Jeffrey, May, and Jason. And we'll see you guys next time. Bye.